Good day. We'll now be discussing check digits or how to compute check digits. So check digits or digit is located at the far right of this barcode. So a check digit or a checksum is used to verify errors on identification numbers. It is a single number, take note, it is a single number generated using the other characters from the identification numbers. So different identification numbers use different check digit schemes. So we will only be discussing these two types of codes, the Universal Product Code and the European Article Number Code. The UPC is used in the US and in Canada. Elsewhere, they use European Article Number or the EAN. In the Philippines, we use the EAN code, now referred to as the International Article Number, to identify products. Now, the UPC, the check digit of the UPC is usually indicated again on the far right of the UPC. And take note of this, it consists only of 12 digits or with 12 digits. The first 11 characters specify the source of the item and the product. The 12th digit, which is the check digit, typically a modulo 10 check digit. Okay, so we have this. Consider this. So this is our notation for the 12-digit UPC. So for the first number, it's A1. Second number is A2 until the check digit, which is A12. Now take note that the odd numbered position is multiplied by 3. So A1 is multiplied by 3, A3, A5, A7, A9, A11. And then we need to add all these numbers. Okay. Now, if the sum of these numbers ends in 0 or it is divisible by 10, therefore the entered barcode number is correct or it is valid. So it's either divisible by 10 or it ends in 0, just like 10, 20, 30, 40, 100, 150, and so on. All of them are divisible by 10. If that is the case, then of course it is a valid barcode. So it's valid. Otherwise, it is incorrect or invalid. Now, to solve for the check digit A12, we will be needing this one, this formula. So A12 is equal to 10 minus this expression until A11 only, mod 10. Okay, for example. Okay, by the way, for this part, this is mod 10. Take note that when we say A mod 10, this is equivalent to the remainder of A over N. For example, 17 mod 6. So take note that 17 divided by 6 is 2, remainder 5. Therefore, 17 mod 6 is equivalent to 5. If it's 345 mod 11, so 345 divided by 11 is 31, remainder 4. So it's the remainder, so therefore 345 mod 11 is equal to 4. Now in our case, this is mod 10. So say for example, we have 26 mod 10. Okay, so basically this is just 26 divided by 10. Okay, you may check that this is just 2 remainder 6. So this is now equal to 6. Okay, if it's 73 mod 10, then this is 73 divided by 10 is just 7 remainder 3. So this is actually equal to 3. So the shortcut for this, when we come to mod 10, is the equivalent is the last number of the digit here. Okay, so that is our shortcut. So meaning if we have 112 mod 10, so this is just equal to 2. Okay, because 2 is the last digit of 112. So no need to do this division. Okay, so let's start. Example 1, consider the UPC 770A32308554. So this is our A1, this is A1, and this is A2. This is A3, A4, 5, A6, A7, A8, A9, A10, A11. So again, we have this formula. Take note, the odd position numbers are multiplied by 3. So this is 3 times A1, which is 7, plus 7, okay, plus 3 times A3, so A3 is 0, plus 8, plus 3 times A5, so A5 is 3. So this is 1, 2, 3, 4, 5. So it's 5, fifth position. 6, so plus 2, plus 3 times A7, so A7 is 3, plus 0, which is A8, and then 3 times A9, which is 8. Then the 10th position is 5, and the 11th position is 4, so 3 times 4. So meaning, in the second line, we just substituted the values from the UPC number from to our formula. Okay, substitute these numbers to our formula. So we have this. You may check using your calculator that you will get 97. So 97 mod 10. So again, we'll just take the last digit, which is 7. So 10 minus 7 is 3. So therefore, the check digit here is 3. Next example. Okay, we have another UPC. This is 11. So we need to find the 12th digit or the check digit. So this is A1, A2, A3, A4, A5, A6, A7, A8, A9, A10, and A11. So substitute all of these to our formula. You have this expression. Okay. Using your calculator, you will get 155. So 155 mod 10, again, we'll just take the last digit, which is 5. So 10 minus 5 is 5. So the check digit of this UPC is equal to 5. Okay, you may do this activity, then I'll just post the answer on the comment section. Next example. Consider the number found at the bottom of a Kellogg's Corn Flakes box. We have this UPC number. Determine how a barcode scanner would detect the error if the above mentioned numbers was entered into a computer as this. So if you notice, the 3 was changed to 5 or is changed to 5. So since this is a complete UPC, we only need to verify whether this expression here is divisible by 10 or not. Remember from our introduction, this number 2, when we add this expression, this one, the sum must end in 0 in order for it to be divisible by 10 and in order for it to be valid. Okay, so let's just check. So this is A1, so 3 times 0 plus 5 plus 3 times 8 plus 0 plus 3 times 0 plus 0 plus 3 times 0 plus 0 plus 3 times 1 plus 2 plus 3 times 7 plus 7. Okay, so A12 is now included because this is a complete UPC. Our previous examples is or was to find A12. So that is why we used this one. But if we need to verify whether it's valid or not, so we will use this complete expression, okay, including A12. So if we use your calculator, if you use your calculator, you will get 62. And take note, 62 is not divisible by 10. And because of this UPC is not valid. So an error is detected. Again, it should be divisible by 10 to be valid. Last example for UPC, suppose that the packaging of a grocery item was damaged in such a way that the fifth digit of a 12 digit UPC was scratched off, but the remaining 11 digits show this one. So we have 1, 2, 3, 4, 5. So this is the fifth position. So we denote it by X. Okay, so determine the correct UPC, meaning we need to find the correct value of X. So take note that it's complete, no? It's just that we need to find X, so therefore we need to do this. We need to use the complete expression including A12. Okay, and it must be divisible by 10 for it to be valid or correct. So substitute, we have 3 times 8 plus 8 plus 3 times 0 plus 7 plus 3 times x plus 2 plus 3 times 3 plus 0 plus 3 times 3 plus 5 plus 3 times 8 plus 4. Okay, so obviously you can just use your calculator by adding and multiplying this or doing the expression. Put it in your calculator or input them. So we have 92. Okay, plus 3x. So we have 92 plus 3x. Take note, it must be divisible by 10. Okay, so we have these conditions or cases. If x equals 1, then this is 95, which is not divisible by 10. If x equals 2, then we have 98. Again, not divisible by 10, and so on. If x is 5 now, again, it's not divisible by 10. But if x is 6, then we have 110, which is now divisible by 10. So therefore, x is equal to 6, and hence it is the fifth digit of the UPC. So this is now 6. So we have 88076230358 as the correct UPC. Okay, and then you may try to answer this. Suppose that the packaging of a box of kitchen tools was damaged such that the seventh digit, so 1, 2, 3, 4, 5, 6, 7. So our X now is on the seventh position. Now it's no longer readable, but the remaining 11 digits were this one. So I'll just post the answer on the description box. Let's now go to the second code, the European Article Number Code. So basically, the EAN and the UPC have quite similar process. They only differ with number 1. EAN has 13 digits, but the UPC have or has 12 digits. Next one, in the UPC, the numbered position that was multiplied by 3 is odd. But in the European or EAN code, we multiply the even numbered position by 3. So take note, we have this. So 2, 4, 6, 8, 10, 12. All of them are multiplied by 3. Okay? And the same with UPC, if we add these digits or numbers, then and the sum is 0, not 0. The sum ends in 0 or a number ending in 0. Therefore, it's divisible by 10. So therefore, if that is the case, the entered barcode number is correct. So in short, it must be the same with the UPC. No, the sum of this one must be divisible by 10 in order for it to be valid. Otherwise, it is invalid. Okay, example. Before the example, we have this. To check or to find the check digit A13, so we have this. So if you notice, they have quite a almost similar formula. It's just that again in EAN, the even positioned numbers are multiplied by 3. In the UPC, it's the odd positioned numbers are multiplied by 3. And take note, it's up to A12 because again, in EAN, we have 13 digits. Okay, find the check digit of this 13-digit EAN code. So using this formula, so A1 is 4, so do not multiply by 3. So 4 plus 3 times 8 plus 0 plus 3 times 0 plus 5 plus 3 times 5 plus 2 plus 3 times 1 plus 6 plus 3 times 9 plus 1 plus 3 times 3. Okay, so we have this. If you use your calculator, you'll get 96. So mod 10, again, we'll just write the last digit, which is 6. So 10 minus 6 is 4. So therefore, the check digit here is 4. Next, find the check digit of this EAN code. So the same thing, the same formula. So this is A1, so 9 plus 3 times 7 plus 8 plus 3 times 0 plus 7 plus 3 times 4 plus 3 plus 3 times 2 plus 5 plus 3 times 8 plus 2 plus 3 times 0. Using your calculator, you will get 97. And 97 mod 10 is just 7. So 10 minus 7 is 3. So the check digit is 3. So last example, what if the same with UPC, one of the digit is not readable or it's damaged? So we will use now the complete formula. So from A1 to A13 and the even numbered position are multiplied by 3. And again, it must be divisible by 10. So using your calculator, this plus this is 98 plus x. So that is why we have 98 plus x. So if x equals 1, then we have 99, which is not divisible by 10. If x equals 2, then it's 100. So now it's divisible by 10. Therefore, the seventh digit, this one, is 2. Okay, so that is our missing digit. Okay, so you may try this. Number 1, determine the check digit. So meaning you just use this formula. Okay. And number 2, to verify if it's valid and it's EAN, then of course you need to use this expression from A1 to A13. Again, if it's divisible by 10, your aim is for it to be divisible by 10. If it's not divisible by 10, then it's not valid. If it's divisible by 10, then it is valid. Thank you for listening.